Hi, welcome to MooMooMath. Today we are going to go through the ambiguous case for the law of sine. So before we start that, we need to practice finding the altitude inside a triangle. So we have a triangle, ABC, and we know one of the angles is 25, and we know this length is 12. So using the law of sine, we would need another piece of information, but we just want to find the height or the altitude of the triangle. So we have to decide which trig function to use. So I'm going to go through and I'm going to highlight really what we're really using, this triangle right here, this right triangle, where your right angles right here associated with the altitude. And we need to find this length over here, or the height of the triangle. So from here, I'm going to use the opposite and hypotenuse. So I'm going to take the sine of 25, and that's going to equal to x over 12. And then I'm going to solve for x, which is your height. So you're just going to stick a neat 1 under here and do cross products. So you're going to have 12 times sine 25. And that is equal to x, or that's equal to my height. So now let me grab my calculator. Whoops, that's my calculator. And I just make sure your calculator is in degrees, so check your mode. And then I'm going to take the sine of 25, get that answer, and then multiply that times 12. And so the height is 5.07. So it's very important you can find that. So really, to find the height, what you're going to do is you're going to take the sine of the angle that you're given times, in this case, the length is 25, but really it's the hypotenuse, right, of the right triangle. So it's the hypotenuse. And that gives me the altitude of the triangle. So just kind of keep that in mind as we're working through this law of sine. Okay, so what are we covering today? We're covering what I call the case of the swinging leg. I also call, it only applies to the donkey rule with our triangles. So what do we mean by donkey rule? Well, the SSA, or the angle given two sides. And in this case, if you have an angle followed by two sides, or two sides and a non-included angle, we're going to use the law of sine to solve that. So on Friday, we learned as a class the law of sine, where you take the opposite side A over sine of A, the angle, and that equals side B, and the opposite angle of that is big B, so sine of big B is equal to C over sine C. And that's the law of sine. So we're going to use that law to solve our triangles, but we have to use these special cases. Okay, so what is the ambiguous case? Well, the ambiguous case only occurs with the donkey rule. So if you're using the law of sine and you have two angles in a side, then you don't have to worry about it. It's only when it's an angle followed by two sides. So here are kind of the scenarios, and if you printed the graphic organizer, you can fill them in one at a time, and I'm going to go very slowly, one slide at a time, but this is basically what we're going to fill in. Okay, so scenario 1, you're going to have an angle and a given side B, so angle A, given side B, a side A, that A is not long enough to reach, so that creates no triangles. Then you're going to give in another scenario, still A, you're given A and little a, and side B, which is now the adjacent side, and A is equal to H, there's one triangle. Third scenario, given angle A, side A is greater than B, this one has one triangle, and given an acute angle A, where side A, little a, is longer than the height but shorter than B, that's our case of 2. and we'll go specifically into that. Now, when you have obtuse triangles or obtuse angle A, it only really has two cases. Either A is not long enough, so it won't create a triangle, or A is longer than B, so it creates one triangle. Now, I know I went through that real quickly. We're going to go very slowly through each case, but just so you can kind of get the sense of where we're going with this. So what are we going to do to figure these out? Well, first you're going to find H, and H is our height, the height of the triangle. Well, that's just like the warm-up we just did. We found the altitude. So you're going to find the altitude or the height. Now, to find the height, you're going to take B, which is your adjacent side, and multiply it by sine of A. Well, that's how you find the altitude of a triangle. We just did that in the warm-up. Okay, so we're going to first find out the altitude, which is also known as the height. You need to think of you also need to look at the fact that is A an acute angle or an obtuse angle. If it's an acute angle, you're going to look at these four scenarios. If it's obtuse, you're going to look at these two scenarios. So we've got 4 cases for acute and 2 for obtuse. And after you kind of look at your height, you decide if you have obtuse or acute, you're going to sketch the outcomes. So you're going to sketch one of these 6 scenarios. And if it's possible, so if you have 1, 2, or this possibility is 1, out of the 6 cases, 4 of them have triangles, you're going to solve the triangles. When we say solve, that means find all 6 parts, all 3 angles and all 3 sides. Okay, so let's look at one case at a time. Okay, so the first case is where A is less than H. Okay, so what's really happening here? Okay, we have a big angle A. We have little side A. And we have a given B. Well, you can see that A is too small. If our height ends up being quite large, okay, and A is shorter than this height, then this leg is never even going to touch the ground. Okay, so kind of think of this as a baby in a high chair and his feet are dangling, and it can never touch the ground. So if A is shorter than the altitude, there is no triangle because that side is not long enough. Case number 2. A is still an acute angle, so we're still dealing with the acute angles. But A, the opposite side A, little a, is equal to H. Well, if little a is equal to H, that means it is going to touch, but it's only going to touch in one place. And it's actually going to create a right triangle. So not only is it one triangle, but it's one right triangle. And usually you'll be able to kind of recognize those. Those tend to be special right triangles. But that's going to be one possibility. So A equal to H is one triangle. Okay, what if A is greater than B? So we've got the given angle, we've got this adjacent side, we can calculate the height, which you don't even really have to do in this case. If this side A is longer than the adjacent side B, if A is greater than, actually, or equal to, this will only create one triangle. Well, let's think about why that's true. Okay, if we've got this given angle A, and you've got a side B, and let's say A is equal to B, so B and A are the same length. That means we're going to have an isosceles triangle. Hey, that's pretty cool, right? That's going to be your isosceles. But if A is actually longer than B, what's going to happen is this side is going to stretch out all the way. So it is longer than the height and it's longer than B. So there's only one triangle that can be created. Okay, so that's a pretty easy one to figure out. Now, this is the odd bird case. This is the reason the angle side side or the donkey rule has that rule, because it actually can create 2 triangles. So angle A has to be acute. So this is an angle less than 90. Okay, A has to be less than B. A is shorter than B. But A is also greater than the height. So let's look at the two scenarios. Okay, we have this side B, we have a given angle A, and we have this side little a that stretches down, but it's shorter than B. And we can create a triangle like that. But we can also create a triangle by taking what I call the swing leg and keep thinking of this top vertex angle as a hinge. What if we swing A inward? Then we still have a triangle. Because remember, B is longer than A, so it actually creates a second possibility. So when does a second possibility happen? It's when A is shorter than B, but A is also larger than the height, so that it can swing in and create the two possibilities. Okay, now let's look at our two obtuse situations. These are a little easier to see. So case one, if A is an obtuse angle and we've got the adjacent side B, and if A is shorter than B, then guess what? It's never going to reach all the way down to this opposite point, because we know by the triangle inequality theorem that if this is an obtuse angle, the other two angles in the triangle have to be acute. Therefore, the opposite side from big angle A, which is little side A, would have to be the longest side. Well, it's not. It's shorter than B. So this creates no triangle. It doesn't create one at all. But what if A is larger than B? So we've got angle A, and it's obtuse, so it's greater than 90. That means side A has to be the longest side, and as long as A is greater than B, then it does indeed create one possible triangle. So those are your 6 scenarios. And now you should have filled out this graphic organizer with all 6 scenarios. And if you need to stop the video and write them all down at this point, you can do that, or you can go back to the other slides. It's the same information. Okay, so let's look at our first case. Okay, we're looking at angle A is 42 degrees, side A is 22, and side B is 12. So let's compare A and B. A is larger than B. So let's look. A is larger than B. Well, that would be true right here, but A is not obtuse. So let's look at this scenario. A is larger than B. That means we're only going to create one triangle. So let's solve that triangle, okay? So let's sketch it out. Whoops, let's get a better line there. Just get a side. So here's one side. We'll call that side B. We'll make the angle at 42. And I'm going to stretch this out so it's a little more to scale. Okay, and that side's going to be our side A. So this is going to be angle A, and it's 42 degrees. This is going to be side B, and it's 12. And then side A, which is always opposite angle A, is 22. It's quite a bit larger, so it's going to stretch out. And we're going to solve the rest of the triangle. So that makes this angle B, this angle C, and this side C. Now to solve the triangle, so I can find my height just to confirm that indeed we can create a triangle. So to find this altitude or this height, I'm going to take B times sine A. So B is 12. B is always your adjacent side, times sine of angle A, which is 42 degrees. So let's grab my calculator. I'm going to take 12 times sine of 42. And that's 8.02. Okay, that's really insignificant at this point, but I do want you to see that the height is only 8 and A is longer than the height, so we can create one triangle. Okay, the angle is acute, so we've looked at our acute cases. We've decided that it's got one possible scenario. We've sketched it. Now we just need to solve. So using the law of sine, I'm going to set this up. I've got 22, which is side A, over sine of 42. So side A over sine of angle A. Now the side I know is 12, which is B. So I'm going to solve for sine B. To calculate this, we're going to cross multiply. So 12 times sine of 42, that's what we've already done. That is equal to 22 times sine B. So to solve it for sine B, I'm going to divide by 22. So I'm going to take the answer, which is the height I just got, which was 8.02, and I'm going to divide that by 22, and I actually have sine of B. So let's divide this, because I've already calculated it, by 22, and we get 0.3694. Now there's some more decimals. I'm not going to worry about writing those down, but let's write that step down so you can see what's happening. Now to find this angle, I've got to take the inverse sine of this ratio, 0.3694. So inverse sine of 0.3694 will give me the angle B. So grab your calculators, and we're going to do second sine, and I'm going to pull that answer up by doing second answer, and it's 21.4. So B is 21.4 degrees. Okay, now I've got two angles and two sides. To get my third angle C, that's going to be pretty easy. I know that a triangle adds to 180, so I'm going to take 180 and I'm going to subtract 21.4 and I'm going to subtract 42. And I'm left with 116 whoops, I didn't get the decimal there, 0.6 degrees. So there's my angle C. Now the only thing left to solve for is side C. So let's go back. I'm going to set up my ratio for law of sine. 22 is A. Sine of the angle A is 42. I now know C is 116. So I'm going to take sine of 116.6 degrees and solve for side C. So let's do a cross multiplying. So this time it's 22 times sine of 116.6. And you can go ahead and type that in your calculator. That's fine. And then you're going to set that equal to C times sine of 42. And you're going to divide both sides by the sine 42 to solve for side C. So when you're solving for a side, you don't have to worry about doing the inverse. It's only when you're solving for an angle. We've just finished inverses, so that should be pretty easy. So let's look at this. We're going to take 22 times sine of hit the wrong key there, 116.6. I'm going to get that answer. I'm going to divide that by sine of 42. And that is side C, which is 29 point. I'm going to round that to 4, 29.4. So this side is 29.4. Now let's use our number sense. Okay, our smallest angle is 21. Opposite side is the smallest side at 12. The middle-sized angle is 42, and the middle-sized side is 22. The largest angle, which is quite significantly larger at 116, Opposite that is a side of 29. So you can solve the whole triangle with all 6 parts and kind of use number sense to check it. Okay, let's look at scenario 2. Okay, scenario 2, we have angle A that's 85, side A that's 15, and side B that's 25. So let's do a quick sketch. Okay, 85, that's a pretty big angle. So I'm going to just give myself a working line on the bottom. Then we have a side of 15 over here. So we've got 85 degrees for angle A, 25 for side B, and 15 for the opposite side from 85. Now, if you can see this, A is less than B. A is shorter than B. So we have to be really careful here. We have to look at this scenario. We need to look at this possible scenario. We need to look at this possible scenario. Now, since A is not obtuse, we're going to just eliminate these two this time and just look at these 3 possibilities. So it could be none, 1, or 2. So let's check it. We need to compare it to the height. Does this even create a triangle? Well, to find the height, what are we going to do? We're going to use B sine A. So B is 25. We're going to multiply it times sine of 85. So just guessing, think about this. Do you think this is even going to create a triangle? So we're multiplying 25 times sine of 85. And our height is 24.9. So it's almost as long as B. Well, guess what? A is too short. A is not going to reach it. A is only 15. The height is 24.9. So it's one of those little toddlers sitting in a high chair with his feet dangling. It's not going to reach the floor. So this one has no triangle or none. This one does not even create a triangle. So you don't have to solve it. So that's kind of nice. You just stop and say no triangle. Okay, so let's look at the third scenario. Okay, we've got angle A at 20.5, side A that's opposite it, that's 12, and side B that's 31. Okay, side B is pretty big this time, so we got to be careful. I'm going to draw this somewhat to scale. Okay, so I got a small angle, and then I got side of 31, and then a side of 12. Okay, let's label it. So this angle is 20.5 degrees, and this side is 31. That's A, that's adjacent side B, and then side A is opposite angle A. Now, let's look at our scenarios. Again, it could be this one. It could be this one. A is not greater than B, so we're not using that one. But it could be this one. And of course, A is acute, so we're not using the 2 obtuse possibilities. So this is kind of like the last one. It could have none, 1, or 2. So let's check the height. Let's see how it compares to the height of the triangle. So I'm going to take B sine A. So let's take 31 times sine of 20.5. And let's see what we get for the height to see if it creates a triangle. So 31 times sine of 20.5. So the height of the triangle is 10. Okay, whoops. I touched that too fast. It's 10.9. So what's happening here? How many triangles will this create? Well, is A long enough to create a triangle? Yes. A is longer than the height. A is not shorter than the height, so we can eliminate none. A, is it equal to the height? No, A is longer, so it's not 1. So this is the case of 2. This one creates 2 possible triangles. So we just found out that if A is greater than the height, which 12 is bigger than 10.9, but it's less than B, and A is less than 31. So let's plug it in. We got 10.9 is less than 12 is less than 31. This is a true statement, so this is a 2 scenario. Now let's solve for those 2 possibilities. Okay, well, the first one's pretty straightforward. We're just going to treat it like it's drawn. So we've got, let's put this here. I'm just going to put 20.5 into this corner. I'm going to type it up so it looks a little neater. This one is 31. And over here, this one is 12. Now, I'll draw now. So this is A, and this is side A. This is B, so this is angle B. Let's solve for angle B first. So 31 over sine B is equal to A, which is 12, over sine A, which is sine of 20.5. Let's grab our calculators and take 31 times sine of 20.5. So I'm just doing a cross product. Get that answer, 10.85, and then I'm going to divide it by 12. And that's equal to sine B. So sine B is equal to the decimal. Let's look at it again. 0.9047047. To find the angle, I've got to use my inverse. So sine inverse is my next step of 0.9047. So in my calculator, I'm going to do second sine of the previous answer. And I get 64 points. Let's round it off to 8. 64.8 degrees. That is angle B. So let's put that over here. That's 64.8. Now we can just use our calculators to find C. We can take 180, which is the sum of the triangle, minus 20.5, minus 64.8. And that gives us 94.7. So angle C is 94.7 degrees. Okay, that is C. Now we can use the law of sine to find sine C, or side C, in just a second by taking A over sine A is equal to C over sine of C, which is 94.7. I'm not going to do that. Well, let's go ahead and do that step. So let's take 12 over sine 20.5 is equal to C over sine of 94.7. And then do our cross products, 12 times sine of 94.7, and that's equal to, so let's type that up. So 12, I'm going to bring this down a little bit. Here we go. Of sine 94.7, that's equal to C times, let me use the star for times, sine of 20.5. So we're going to end up multiplying this together and then dividing by 20.5. So let's grab our calculators. 12 times sine 94.7. Get that answer. Then divide it by sine of 20.5. And that should give us side C, which is 34.2. So that's 34.2. Now let's use our number sense. Okay, the smallest angle is 20.5. The smallest side is 12. The middle sized angle is 64, so the middle length is 31. The largest angle is 94.7, so the largest side opposite it is 34.2. So number sense, that's all working. So there is triangle 1. We've solved it. So we've got to go back and solve for triangle 2. What is this other possible scenario? Well, I'm going to erase most of this, okay, except for angle B. Okay, angle B, we ended up with, let me go back and see if it's on my calculator screen, 64.8. Okay, so that's important that we keep an eye on this angle B, 64.8. Okay, we know we were given the angle A, side B, and side A. Everything else can change. Well, indeed it does, because instead, since A is shorter than B and A is 12, the other possibility is this length of 12 swings inward. Well, what's going to happen to B? B is no longer 64 degrees because this angle, let me draw it with an arc. This angle is obtuse. It's not acute anymore. But this 64 does help us. So let me show you how it helps you. Okay, remember the original way we drew 12 as swinging outward. And I'm just going to kind of keep that here, thinking about this, the fact that this is 12. If we take that 12 and we swing it inward, what kind of triangle is this little reference triangle right here? Hopefully you see, hey, that's an isosceles triangle because we got a side of 12 and a side of 12. So these two are the same. Well, what do we know about isosceles triangles? They have base angles that match. So if this angle at B of the original triangle is 64.8, that means this angle is 64.8. Okay, well that's going to help us because this interior angle, I'm going to erase this arc for a second, and I'm going to move angle A just back slightly just to get out of the way so we can focus on B. Okay, the new B, I'm going to call it B prime because this is the original B and this is the new B. Okay, this arc is an obtuse angle and it is a linear pair with a 64.8. What does a linear pair mean? It means the two angles add to 180. So I can figure out this new angle B by literally subtracting it from 180. So I'm going to take 180 and I'm going to subtract 64.8, which was my original B. And I'm going to get 115.2. 115.2 is the other possibility for B. So A is going to remain 20.5. That was a given. There's nothing we can do. It's not going to change. Side B, it's going to remain 31. It was given. Side A, little a, that's still 12. But what is going to change is angle B, angle C, and side C. So since angle B is now the obtuse angle, that means side B is now the longest side. And then C over here is going to be kind of small. This angle up here is going to be small, and its opposite side is going to be kind of small. So let's calculate the new C. Well, to calculate the new C, I'm just going to take 180 minus A, which is 20.5, and minus the new B, which is 115.2. And we get a new C of 44.3. So 44.3 is my second possibility. So I'm going to call that C prime. And then what about little side C? Well, Little side C, I can calculate the way I did the first time. I can take I can set up the ratio. Let's set up the ratio, and we won't use that yet. Okay, I can take side A, which is 12, over sine 20.5, which is angle A. And I'm going to set it up equal to the side C, which we don't know. That's now the little side C, so let's call that little side C prime. Opposite sine of big C, which is our new C, 44.3. So cross multiplying, we're going to take 12 times 44.3 is equal to C times sine 20. So what's going to change right here is this angle. 44.3 is now the new angle for C. So let's grab our calculators and take 12 times sine of 44.3. Get that answer. We're going to divide it by the sine of 20.5. And we're going to get 23.9. So this side over here is 23.9. Now let's see if that makes number sense. Okay, the smallest angle is 20.5. The smallest side is 12. The middle sized angle is 44.3. So this is the middle size length at 23.9. The largest angle is 115, and it's opposite the largest side, which is 31. So all that makes number sense. So here is a possibility of two triangles. And that's when you've got what we call the swing leg, where A is shorter than B, but A is longer than the height, so it creates a swing arm. So there are your two possible answers. So let's look at a second case of two. If you understand it, you don't need to watch this. But if you don't understand this, this is a good one to watch because this will help you see the second case. So here's angle or side A at 20 degrees. Side little a is 11 and side B is 20. So let's check our height. So to find the height, we're just going to take the adjacent side, which is 20, times sine of A, the given angle, which is 20. So the height is 6.8. So this height, 6.8. It's shorter than the side 11, so indeed we can have a swing arm. So we're going to have two possible triangles. So let's kind of set it up. We're going to take 11 over sine 20 is equal to 20 over sine B. So let me label this B and grab your calculators and take 20 times sine 20, which we just got a second ago. I could have just used that in the calculator because that's just the height. And then we're going to divide that by 11, divided by 11. And that gives me the sine of B. So I'm going to do inverse sine to get the angle. Whoops, what did I do wrong? Oops, I forgot to put my second answer. And I get 38.5. So this is, I'll just round it up to 38.5. 1 decimal place for angles is plenty. Now to find C, let's take our calculator. 180 minus 20 minus 38.5. And that gives us 121. So 121.5, and that's C. So I'm going to list this all out. So A is 20 degrees, B is 38.5 degrees, and C is 121.5 degrees. Little a is 11. That was given. Little b, that was 20. That was given. And then little c, we haven't solved for yet. So let's go back and set up and solve for c. So I've got a over sine a is equal to, I'll switch colors so we can remember this is the second one. Okay, c over sine c. Well, sine of 121.5. So let's do a cross multiplying. So we have c times sine 20 is equal to 11 times sine of 121.5. Grab your calculators. Let's calculate that. So 11 times sine of 121.5 equals, and then divide that by sine 20, and that should give us c. So c is 27.4. So c is 27.4. And that's our third side. So I'm going to add that over here. So there's our first set of triangle lengths. Okay, now we need to go back and find the second set. So I'm going to erase all this work, and we're going to look at when the arm swings in. So this angle C is no longer angle C. Angle B is still angle B, but we're going to move it. Remember, it becomes the other base angle of this isosceles triangle. So now I'm going to focus on, and let me darken it in purple, or in green. Say a given side of 20. My swing arm is now swinging in. This one is 11. And this side over here is C. We don't know it yet. This angle up here is C. We don't know it yet. And we don't know B. And remember, we're going to call the second set the primes. So C prime, B prime, little c prime for the little side, big C prime for the new angle, and big B for this new interior angle. We're going to use the fact that this is 38.5 to help us find B prime. Okay, remember how we did that? Those two are linear pairs. So we're going to take 180. We're going to subtract 38.5. So B prime is 141.5. So let's just minimize that for a second. 141. I'm going to go back, and A in my new triangle is 20. B, we just found it to be the linear pair with this one, 141.5. C, whoops, I need to call these primes. C prime, we don't know yet. Okay, A, little side A, still 11. That was a given. Side B, that was also a given. It's 20. But side C, we're going to call that little c prime. We don't know yet. Okay, well, the easiest one to get, of course, is this C prime, because the angle, because we know they just add to 180. So let's go up here. Whoops, sorry about that. We're going to take 180 minus angle A, which is 20, minus B prime, which is 141.5, and that gives us C. Ooh, C is tiny. C is 118.5 degrees. So what does it tell us about side C? Side C is going to be smaller than 11. So this was 118.5, and that's smaller than A, therefore the side C is going to be even smaller. So let's use our ratio we were given. 11 is to sine 20. So we're using A and angle A. C we don't know. I'll call that C prime. And sine of 18.5 degrees. So cross products, let's think 11 times 18.5. So 11 times sine of 18.5 divided by the sine of 20. and that will give us C. 10.2. 10.2. So let's see if that makes sense. Is it smaller than A? Yes, it is. A is 11 and C prime is 10.2. So it is the smallest side, and it's just slightly smaller than A, but that makes sense because angle C is only slightly smaller than angle A. So that's how you do the ambiguous case when you have two possible scenarios. Now, I've got one more set of problems. This is on your homework, so I wanted to do an example of one of these. It says, determine the value of B given side A is 5, angle B is 25 for each scenario. So, if we're given an angle and an adjacent side, now notice this one's a little bit different. Angle B and side B, they're going to be the ones opposite each other. Side A this time is the adjacent side, so you just got to be careful when you draw these. Okay, these variables are kind of interchangeable, so just make sure you label your triangle with the given angle, with the associated opposite side, because that gets a little confusing on the homework. Okay, so if this is angle B and it's 25 degrees, side A would have to be the side next to it. And then what would be the length of this side B opposite angle B to create one triangle? Okay, so let's look at the scenarios for one. Here's one, and here's one. Okay, those are the scenarios. Now, it says A is obtuse. Well, we already know the given angle. In this case, our given angle is not really A, it's really B. B is not obtuse. So this scenario will not work. But we will look at these two scenarios, this one and this one. Okay, when A is acute, but we're going to substitute letter B here because that's the given angle. B is the acute angle. Okay, if B is the acute angle, what would be the opposite side have to be? Well, for it to be one triangle, it could be the same as the height. So what would the height be? Well, let's grab our calculator, and we know to find the height, we take sine of the angle, and we take it times the adjacent side, 5. That's just using sine. So B could be equal to 2.11, which is just the height of the triangle. So that's the scenario where B is possible, okay? So, I'm sorry, that one triangle is possible. So that would be B would be exactly equal to that height, and we create a right triangle. That's this scenario. Now let's look at the second one, where the opposite side has to be greater than the given adjacent side. Since our given adjacent side is 5, if B is anything bigger than 5, then it can't swing. So then we could say B, whoops, let me switch colors. B could be greater than or equal to 5. If it's equal to 5, it'll actually create an isosceles triangle. But if it's anything greater than 5, then it will stay one triangle. So that's this scenario right here. So what are the answers? For one triangle, B would have to be equal to 2.11 or it has to be greater than 5. Those are the two possibilities. Okay, so now let's look at no triangle. In order for there to be no triangle created, let me erase this for a second. Okay, no triangle, this is the only case we're looking at right here, because we know that A is not obtuse, or in this case B is the given angle. B is not obtuse, it's acute. So we're only looking at this scenario. That means this opposite leg has to be shorter than the height. Well, we just calculated the height. The height was 2.11. So that means B would have to be less than 2.11. Then if B is less than 2.11, it's too short to be a triangle. Now let's look at case with two triangles. So what's the case with two triangles? Two triangles occur if the opposite side is less than the given side, but greater than the height. So that puts side B taller than the 2.11, but less than 5. So it's greater than the height, but less than the given adjacent side. And that's how you figure it out. Okay? So for one triangle, we said B could be equal to the height and create a right triangle, or B would have to be greater than or equal to 5 to create the isosceles, or this longest side. If B is less than the height, then it's not going to create a triangle. But if B falls between the two, that both the height and this opposite side, then that creates the swing arm, and we have two scenarios. So hopefully that kind of helps you see that scenario. So we're going to stop here after quite a long lesson. You can go back and repeat, or you can skip whatever you need to, but hopefully you have enough information to go on. You can complete worksheet 2 on the ambiguous case and come with questions on Thursday. I hope this video was helpful.